Determine whether the series is absolutely convergent, conditionally convergent, or divergent, with the sum from 1 to infinity n factorial over e to the n squared. When asked the question in this format, we want to first consider the series of absolute values. But looking at the current series that we have, there's no negative terms anyway. So all the terms are positive. That means that we either converge absolutely or we diverge. Just deal with the original series as if it was a converge or diverge question. When you see a factorial, definitely want to use the ratio test. Divide successive terms. Quickly that can be found by creating the same number of fractions as you have terms. Take the terms where they are, replace n by n plus 1. In the gaps, put the associated terms from the original series, and then cancel. Now this one's kind of tricky here, how this one cancels. What we need to do is take a close look at e to the n plus 1 quantity squared. N plus 1 quantity squared is of course n squared plus 2n plus 1. So e to that is going to be e to that. But we need to cancel with this e to the n squared. So we can rewrite it again as e to the n squared and then e to the 2n plus 1. By doing that, that isolates this term e to the n squared to cancel out with the numerator's e to the n squared. Denominator, it just cancels by factoring out the n plus 1 and leaving yourself with n factorial. Ultimately, no need for absolute value. We're left with n plus 1 over e to the 2n plus 1. That goes to 0. We can just argue that based off the fact that the denominator is exponential while the numerator is polynomial. If your denominator grows faster than your numerator, the limit's 0. Great. Let's go to the next slide to conclude. 0 is definitely less than 1. So we're doing the ratio test and we got a 0 out of it, which is less than 1. And so because of that, the ratio test says that we converge, but that convergence is absolute convergence. Anytime you do the ratio test, because the absolute value bars, if you get convergence with the ratio test, that actually is absolute convergence.